Good evening, students. Today we will start projecting a pentagonal lamina, 25 mm edges. Let me go through the question. Pentagonal lamina having 25 mm edges is placed on one of its corners on HP. In the earlier videos, we have seen a lamina resting on one of its edges on HP. This is a question resting on one of its corners on HP. Now we'll start projection of the lamina resting on the corners on HP, such that perpendicular bisector of the edge, this is important, the perpendicular bisector of the edge passing through the corner on which the lamina rests is inclined at 30° to HP and 45° to VP. Draw its projection. There is one more difference here in this question. That is, first thing is it is resting on one of its corners. Second thing is perpendicular bisector of the edge passing to the corner on which the lamina rests is inclined 30° to HP and 45° to VP. Earlier questions, lamina used to incline to HP at 30 to some angle, and one of its edges is inclined to VP at some angle. But here, lamina inclination is not given, edge inclination is given. Instead of that, they have given the reference edge as perpendicular bisector of the edge passing to the corner on which the lamina rests. Okay, what is perpendicular bisector? We know we can cut the line into two equal parts, drawing a perpendicular to it. It's called perpendicular bisector. Okay, let us start with the projection of the pentagonal lamina resting on the corner. Then you'll go to that perpendicular bisector in the next second position. Okay, first position is always keeping parallel to HV. We get the top view, and which is the two shape of the lamina. Here, pentagonal lamina in two shape we can see in the top view. So let us construct a pentagon with a 0.5 mm line thickness. Click on the mouse here, then leave the mouse, enter the values in the keyboard. 25 mm is the length, press enter key. Then first angle is 0 because we have to start with the horizontal line. Next 25 mm is the length, second angle is 72°. Next length is 25 mm, enter, press enter key. Then angle is 72 into 2. Then again length is 25, press enter key. It asks you angle is 72 into 3. Then 25 the length, enter key, angle is 72, 72 into 4, enter. Now, because it's resting on the corner, we have to rotate it. Select it by selecting tool, go to rotate command, rotate, copy off, ensure that copy is off. This blue color ensures that copy is off. Then read here, click for the center of rotation. This apex of the pentagon is the center of rotation, and center of the base of the pentagon is the point to rotate from. You can see the center point symbol adjacent to the cursor. Then click it, rotate it by 90°. We can watch for the 90° symbol adjacent to the cursor. Moment you get that, left click, then go to move command, keep it at a correct place wherever you want. So copy was on. So but let me delete this. I should have set up the copy. Anyway, okay. So let me name it. This is A, B, C, D, E, A, B, C, D, E. Next, go to line command, thin line, draw the projection line from all the corners, corner A, corner E, corner C, D. Okay. This angle, this line is 725 mm. Now go to line command, take a 0.5 mm. We know that front view of a lamina is always a straight line because it doesn't have the height or a thickness. So this is the starting point. First line, scroll on this vertical line, get the endpoint symbol, click. This is the one line. Draw one more line, separate line, scrolling vertically on the end projection line from the corner A. You get the endpoint symbol. So this is like this. You have to draw two separate lines. Don't draw a single line from one end to the other end. Then A dash. This is B dash bracket E dash. C dash bracket D dash. C dash bracket D dash. Then rotate. Move, copy on, move from this corner A dash, keep it on the XY line, then rotate, what is the angle given? Yeah, he has not given lamina inclined to HP, or he has given perpendicular bisector is inclined to HP at 30 degree. What is perpendicular bisector? Let's understand now. Before going there, what is perpendicular bisector? Perpendicular bisector is a line, uh, this is the edge CD opposite to the corner A. So if you draw a perpendicular bisector to CD passing to the corner A, this is the called perpendicular bisector. Let us call this name as M1. AM1 is the perpendicular bisector. Now here C D dash is there na. Adjacent to D dash we will have M1 dash also, because you cannot see that. So here AM1 is the perpendicular bisector passing through the corner A, which is resting on the corner A. So that's why we kept the corner A to our left side. Then this the line AM1 is the perpendicular bisector to the edge opposite to corner A, that is CD. What is the length of the perpendicular bisector here? It is 38.47. Okay, now the perpendicular bisector is inclined at an angle of 30 degree. See, perpendicular bisector of the edge passing to the corner on which the lamina rests is inclined 30 degree to HP. Perpendicular bisector is inclined at 30 degree to HP. So this one, A dash and C dash D dash M dash is the perpendicular bisector. Let us rotate it. Rotate. This is the center of rotation. This is the point rotate from. Rotate by an angle of rotation angle 30 degree and position angle both are 30 degree plus enter key. Measure the angle. This is the angle. Within this we have M dash also, M1 dash also. Now go to line command. Draw the vertical projection from the C dash. Switch on the alignment indicator. You can see the alignment how it is aligning itself with the C. Again draw the horizontal from D. It meets, draw one extra line and then trim it up like this. Then draw the, see, we have done the two separate lines. This is one line and this is one line. If you scroll on this line, you will get 10 point symbol. That's why I told you to write two separate lines here. That's the advantage of writing the two separate lines. E to E, next D to E, A dash. This is A, B, C, D, and this is C. Now join A to B, B to C sequentially to get the apparent shape in top view. Now this is the apparent shape. Now we will draw the perpendicular bisector passing to the corner A to the edge CD. This is the perpendicular bisector. Remove the extra edges. Then type this is M. So AM is the median length, apparent median length. Let us measure what is the apparent median length, 33.32. 38.47 is the original length of the median, the perpendicular bisector. It is reduced to 33.32 after inclination to 30 degree. This is the apparent length of the perpendicular bisector. Now, inclination to VP is 45 degree and perpendicular bisector is making an angle. That's the what it has given. Yes, reference edge given is 45 degree. Here, since the reference edge is making an angle of 45 degree, which is the reference edge here? AM1 perpendicular bisector or AM. Both are perpendicular bisector. AM1 is original length of the perpendicular bisector. AM is the apparent length of the perpendicular bisector. Which one you have to take? Usually, when in the other previous problems, what we did is, for example, in this case, this is another problem, previous problem where pentagonal lamina resting on the edge AB 25 mm. This length 25 mm remains 25 mm in the second set of figure, second top view also. It will not change. Other length of the other length may change. Like see, BC is 14.18. Here BC is 25 mm. Like this, length of other edges have changed, but AB remains the same. Reference edge is remaining same from first figure to the second figure. But this is not a case here. Here in this question where reference edge AM1 is 38.47 in the first figure and AM is 33.32. Almost 5 mm it is reduced in the second set of figure. In such cases, which length you have to take? Because bigger length or the smaller length? This is the question arises to us. Let us first draw the 45 degree line. Okay. Now on this line, what is the length you have to take? That's the question. 45 degree. Now, because the length is changing, which one you have to take? Usually, we used to take it from the second set of figure. But in the second set of figure, we are getting median length is different. In such cases, what you have to do? You have to find out one more angle. That angle is called beta angle. And this question is called beta angle question. Let us see how to find out one more angle. This 45 degree is the true angle, and this will measure the true length first. True length of the media by perpendicular bisector is 38.47. Click here, any point on the 45 degree line, type 38.47. Length of the line is 38.47. Enter. And at the end of this line, draw the locus. Draw the locus. So this is A, this is M1, and this line is called locus of M. Locus of M. So this is a different method to find out the one more angle. You have to do all these things. So first we are going with the original length of the perpendicular bisector, 38.47. Now we will go to the 33.32. What is that? 33.32 is the apparent length of the perpendicular bisector. Click on A. It asks you the angle in the ribbon bar. Ribbon bar I type 33.32. I had to draw an arc of radius 33.32. Then it asks you the sweep angle in degrees, but don't enter anything there. Bring the cursor, click here and draw the manually the sweep the arc. Then go to trim command, this one. Trim the arc which is crossing the locus line here. Then go to line command. Scroll on this arc. Read the endpoint of the arc. Scroll on this line AM1. Read the endpoint A. Join it. Then go to within the trim command, there's an extend to next command. Select that and select this line. It will extend. Okay. Then measure this angle. So beta angle is 55 degree in this case. So understand how when we have to find out beta angle, when the reference edge is changing the length, you have to go for the beta angle. So this is the procedure to find out the beta angle. First you have to take the original length, then locus of M. We have to cut the locus of M with help of a apparent length of the perpendicular bisector. That is 33.32. Extend this line, it will meet the actual line and measure the angle. This so. Now what you will do? Select the second top view like this. Select the second top view like this. Then move, copy on, move from A, keep it on the end of this line, one more A, come out and right click. Then rotate, copy off. A is the center of rotation, M is the point to rotate from, rotate it and scroll on the arc, you'll get the endpoint symbol. Can you see the endpoint symbol adjacent to the cursor? Moment you get the endpoint symbol, you have to stop it. So this is how you have to keep the second top view onto the 45-degree line. Now this original and 38 point portion is not required. I'll just delete it now. It's not required. It's no more required for the our next projection. So name it A B C D E, and this is M. This is M. Project vertical line A from B E C D. Now name this point. This is C dash, D dash, E dash, A dash, B dash, C dash, D dash, E dash. Okay. Now go to line command. Take a dark line. A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, E dash to M dash. This is the final end view. If you want to project the end projector perpendicular bisector, draw the vertical from M. It meets here. So this is the end projector. Not required to project, simply I'm showing. Okay. With this, we'll come to the end of this question.